So this is question 4 on the sample assessment materials version of the higher tier paper 2 for GCSE Edexcel physics. Figure 8 shows an airport worker refuelling an aircraft. Pumping fuel into an aircraft can be dangerous. The worker connects an earth wire to the aircraft before pumping fuel. Give one reason why earthing reduces the risk of fire. Just as a point, they absolutely love these questions about static electricity. It's a really good topic to read up on because the questions are generally quite similar. So, earthing the aeroplane, it discharges the plane, or aircraft is probably right, to prevent sparks. So, as it will ask us in the next question, as an aeroplane travels through the air, it can build up a static charge, and if that static charge isn't discharged, it could just jump. And when it jumps, that's a spark, and if there's a spark near a fuel tank, that's pretty bad news. So then part 2, explain how an aircraft can be electrically charged as it flies through the air. So how does anything become charged? We're going to think about charging via friction. Well, there's friction between the plane and air, which causes electrons to transfer between them. And the words you're going to have there are friction, electrons, and transfer. If you were told that for example, the aircraft becomes positively charged, then you'd have to say that the electrons transfer away from the aircraft, and if it became negative, they transfer to the aircraft, but you're not told which way it's charged, it's just that they transfer in one direction, we're just not sure which. Part B, fuel weighing 230,000 newtons is pumped into the aircraft. This fuel moves upwards through a vertical height of 4.7 metres. The power developed by the pump is 1600 watts. Calculate the time needed to refuel the aircraft. So I'm going to think what I've got. I've got here a weight, I'm told a height, I've got a power, and I want to know a time. So I'm going to think about equations that have got these in together. Now I know that power equals energy over time. And if I'm pumping the fuel upwards, I'm giving the fuel GPE. And GPE equals mgh, as we know from the first question in the paper. Conveniently, mg is also equal to W. So weight equals mg. So I can say that GPE equals weight times height. So I'm going to work that out. So the weight, we're told, is 230,000 newtons, and it travels up 4.7 metres. So that gives me GPA of 108,100 joules on the calculator. And now power equals energy over time. Therefore, time equals energy over power, which is 108,1000 divided by the power, 1600. And it comes out as 676 seconds, which doesn't seem ridiculous. Okay, that's going to be 600 seconds is about 10 minutes, so 11 minutes or so, which doesn't seem stupid for a massive aeroplane. That common sense check is really useful to do. Then, figure 9 shows an electrostatic method for spray painting a car door. The car door has a negative charge. The droplets of paint receive a positive charge as they leave the spray gun. Explain how charging the door helps the paint to form an even coating on both sides of the door. You should use ideas of forces and fields in your answer. This is one of the ones where the mark scheme I think is a bit weird and a bit ridiculous. I want to do what my version would be nowadays. And I'm going to think about the idea of an even coating on both sides. So to start with, the paint droplets repel each other because they are all positively charged. This spreads them out even for an even coat. Spelled that wrong, sorry. Then the negative door attracts the positive droplets, and it's asked me to use ideas of fields. I'm going to whack that in here. Due to the interaction of their opposing fields. So whenever you've got a charged object, it has a field around it. If you've got two of those charged objects, their fields can interact, and whenever they interact, it causes a force. So the negative door attracts the positive droplets due to the interaction of their opposing fields, causing a force between them. This helps the paint stick. And I think that's a perfectly good answer, a very, very nice answer for that question. The mark scheme, if you look at the mark scheme, you will notice it's a little bit more ishy, I would say.